Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Vina Agustina from class 19.2A.28. Today I will be presenting a comprehensive look into computer system and hardware. In this 10-minute session, we will break down the machine into two distinct parts: the logical system that defines how computer thinks and the physical hardware that acts as its body. We will explore that these components interact to perform the complex tasks we rely on every day. Let's begin with our first topic on slide 2. Understanding the computer. Now looking at slide 2, let's start with the fundamental question. What actually computer? Beyond the screen and the chassis, a computer is an electronic device that manipulates data. It has distinct ability to store, retrieve, and process information. Most importantly, it is programmable machine, meaning it follows a list instruction which we call software. Without instruction, the physical machine is just inert material. Let's move into slide 3 to see how this system is structurally organized. As you can see here, the slide 3, almost every modern computer follows what we call the von Neumann architecture. This foundation model consists of the central processing unit, a control unit, memory unit, and input-output interface. The genius of this system is that it stores both the data and the instruction in the same shared memory space. This allows the computer to be incredibly flexible, changing its entire function just by running a different program. Now let's flip to slide 4 to see data actually flow through this architecture. The data cycle, or IPO. On this slide 4, we break down the core operational flow using the input process output or IPO cycle. First, input. Raw data enters the system through peripheral device. Second, process. The CPU performs logical and mathematical operation on data. Third, output. The processed data is converted back into readable information for data user. This cycle repeats billions of times every single second, which creates the seamless experience we see on our screens. With the logical system covered, let's now transition to the physical reality on slide 5. Moving into the slide 5, we begin our deep dive into physical hardware with the motherboard. This is the primary printed circuit board of the computer. Think of it as the ultimate communication hub. It contains the chipset, which acts like a traffic controller, ensuring that data moving from the CPU to the graphic card or storage arrives at data exact right destination without any collision. Let's take a closer look at the brain attached to this board on the slide 6. Now, on the slide 6, we have the CPU, the structural brain of the machine. Its performance is determined by its log speed measured in gigahertz and its core count. A modern CPU constantly runs the fetch decode executed cycle. It fetches an instruction from the memory, decodes that what it meaning, and executes it. Modern processors use multiple cores to handle different threads of instruction that exit at the same time. But where does the CPU get this instruction so quickly? Let's find out to slide 7. Looking at the slide 7, we can see that memory organized as in a strict hierarchy. RAM is our main temporary workspace. It is volatile, meaning it wipes clean the moment of power is cut. But because the CPU is so fast, it also relies on something even quicker called CPU cache. L1, L2, and L3. Cache sits directly on the CPU silicon chip, giving the brain instant access to almost frequent data without waiting for the RAM. Now, what about permanent memory? Let's advance to slide 8. Storage technology HDD versus SSD. As shown in a comparison graph on the slide 8, storage technology has undergone a massive evolution. Traditional hard disk drive use moving mechanical parts and the massive evolution. Traditional hard disk drive use moving mechanical parts and magnesium, which severely bottlenecks perform. Modern solid state drive or SSDs use an IND flash memory, specifically use NVMe SSDs interface directly with the CPU, hitting the data transfer speed up to 17 megabytes per second, making old hard drive look ancient. To complete the hardware ecosystem, let's look at the slide 9. Here is slide 9. We cover the visual processing and human interface. The GPU is a specialist processor designed to handle heavy parallel mathematics, which is critical for rendering image and video. Combined with external peripherals like high resolution for rendering image and video. Combined with external peripherals like high resolution monitor, keyboard, and mic, it forms the interface that allows humans to communicate directly with the internal digital system. Finally, bring us to our last slide. Let's summarize what we've learned. A computer is a flawless synergy of logical architecture that physical engineer. From the motherboard that linked the hardware highways to the CPU that executes the logic, every single component must work in perfect harmony. As technology pushes forward, this component will only get smaller, faster, and more integrated. I hope this dive has given you complete technical understanding of how this machine functions under the hood. Thank you so much for the time and attention. My name is Vina Agustina and I conclude my presentation. Wassalamualaikum warahmatullahi wabarakatuh.